Namaskar. A very good afternoon to our chief guest, respected Dr. Prabhat Kumar sir, DG Directorate General of Mine Safety, our guest of honor, respected Shri Sanjay Kumar Singh sir, Director Technical BCCL, respected Professor A.K. Mishra sir, Director CSIR-Central, Dr. Sujit Kumar Mandal sir, Chief Scientist and HORG of Mine Planning Economics, Mine Subsidence and Surveying, and mine backfilling, Dr. J.K. Pandey sir, Head, Chief Scientist and Head Project Planning and Industry Interface, Dr. Abhay Kumar Singh sir, HORG Water Resource Management, Dr. Siddharth Singh sir, HORG Natural Resource Management, Heads of Administration, Purchase and Finance, all scientists, technical staff, staff from the administration, purchase, finance present in person and connected online, from the regional centers, all invited guests, my dear students, members of press and media, my seniors and peers, ladies and gentlemen. I, Dr. Pallavi Das, Senior Scientist, Department of Water Resource Management, feel extremely privileged to welcome all of you on the occasion of the World Environment Day 2024. World Environment Day was established by the United Nations General Assembly in the year 1972 on the very first day of the Stockholm Conference on the Human Environment. Celebrated annually on June 5th, it provides a global platform for raising awareness and taking action on critical environmental issues. पिछले कई वर्षों से विश्व पर्यावरण दिवस पर्यावरण की सुरक्षा, सतत विकास को बढ़ावा देना और वैश्विक सहयोग को प्रोत्साहित करने के लिए एक महत्वपूर्ण अवसर बन गया है. So let us begin the program being mindful about the fact that the earth does not belong to us. We belong to the earth. आज के कार्यक्रम को आगे बढ़ाते हुए I now request Dr. J.K. Pandey sir and Dr. Sujit Mandal sir to accompany our chief guest, Dr. Prabhat Kumar sir, DG Directorate General of Mine Safety, and our guest of honor, Shri Sanjay Kumar sir, Director Technical BCCL, and our director sir to the dais to take their seats on the dais. Yeah, I have told. This year, the theme of the World Environment Day is Land Restoration, Desertification and Drought Resilience. And the slogan is a clarion call, Our Land, Our Future. We are #Generation Restoration. आज का दिन हमारे लिए बहुत ही महत्वपूर्ण है क्योंकि हम भूमि पुनर्स्थापन, मरुस्थलीकरण को रोकना और सूखा प्रतिरोधक क्षमता की निर्माण पर ध्यान केंद्रित कर रहे हैं. यह थीम हमें हमारे पर्यावरण की रक्षा के लिए और भी अधिक समर्पित होने के लिए प्रेरित करती है. I feel extremely privileged and honored to welcome our distinguished chief guest, Dr. Prabhat Kumar sir, DG Directorate General of Mine Safety. His vast experience and insightful contributions as a policy maker and leader in the mining sector have significantly influenced the safety and regulatory frameworks in our industry. We are also privileged to have with us Shri Sanjay Kumar Singh sir, Director Technical Operations BCCL, a luminary from the industry whose visionary leadership at Bharat Coking Coal Limited has been instrumental in driving sustainable practices and innovations. Ladies and gentlemen, please put your hands together to welcome them. We also have two eminent personalities giving us talks later this evening. Mr. Santosh Kumar Singh, Head of Adani Energy Sustainability Group at Adani Power, who is a visionary in sustainable energy, driving innovative practices and policies. And also Professor A.P. Dimri, Director of the Indian Institute of Geomagnetism. Professor Dimri is a leader in earth sciences with numerous groundbreaking contributions to environmental sustainability. We are extremely grateful to all of you for taking time out of your busy schedule and joining the Environmental Day celebrations. Your presence today not only highlights the importance of this occasion, but also inspires us to continue our efforts towards environmental sustainability with renewed vigor and dedication. May I now request Director CSIR-CIMFR to kindly welcome the dignitaries by presenting a book as a token of our respect. Can I have the books, please? At first, our Director Sir is kindly requested to welcome Dr. Prabhat Kumar Sir. Now, may I kindly request Director Sir to welcome Shri Sanjay Kumar Singh Sir. Now, to inaugurate this auspicious occasion, I request the dignitaries to light a lamp symbolizing knowledge, enlightenment, and positive energy. दीप ज्ञान का प्रकाश है जो हमारे मार्ग को प्रकाशित करता है और हमें सच्चाई की ओर ले जाता है. The act reminds us of our commitment to enlightening the path towards sustainable development and environmental conservation. अब मैं CSIR CIMFR के निर्देशक महोदय से अनुरोध करूंगी और कृपया स्वागत भाषण प्रस्तुत करें.
Thank you, Dr. Palvi. Please and good afternoon to everyone, one and all who are present here, and a very warm welcome to one and all. We are really pleased and honored to have today with us our honorable chief guest, Dr. Prabhat Kumar ji, Director General of Mine Safety, who in spite of his very busy schedule, as you all know how busy is usually DG of DGMS, but in spite of very busy schedule, he very happily agreed that too on a very short notice. So we are very thankful to you, sir, for gracing us, and we welcome a very warm welcome to you, as well as to our guest of honor, Sri Sanjay Kumar Singh sir, Director Technical BCCL, who happens to be alumni of ISM, and I'm not sure whether under his undergrad I have taught him, but definitely I have we have a long relation, and he is a very a good friend and well-wisher to us, to me in particular. So we are thankful to you, Singh Sahab, for gracing us as guest of honor. My dear colleagues, all scientists, technical officers, technical staff, dear students, those who are present here and offline, all the regional centers who are connected online, a very warm welcome to all of you, and good afternoon. This my honor and privilege to be here to welcome you all on the occasion of World Environment Day, as Dr. Palvi was talking about why do we celebrate World Environment Day, and this year's campaign focuses on land restoration, desertification and drought resilience under the slogan our land, our future, and we, the generation restoration. Uh, this is, in G20 we had seen our slogan, one earth, one family, one future. And that is so pertinent to us. We have been talking, in the recent past, we have started talking about the ecosystem, the one earth, one planet, or one future. So this was the in our system since thousands of years. And now the impact, particularly the climate change, the global climate change, which used to be discussed by the environmentalists, by the scientists, used to be considered as a topic of research, and now it is no more a dream or a fiction movie. It's reality. Now everyone across the globe has started feeling the impact of global climate change, which is happening around. The way the droughts are being brought in at different parts of the world, the flooding pattern has changed. The rain pattern has changed. The heat wave has, the pattern of the heat wave has changed. The pattern of cold, or the winter, the pattern of winter, and the duration of winter, the duration of summer is changing. It's visible to us. Apart from that, the glaciers are shrinking. That is also a hard fact. It's known to all of us. So now the impact of global climate change, whether the climate change or the pollution, what we say, or let it be the pollution in terms of land, water, air, or all kind of pollution, or the waste which is being created because of industrialization or urbanization or because of XYZ. But the hard fact is it has been felt across the globe. In India, we can also see the impact of global climate change. Water has become a scarce commodity, a resource. One of the scarcest, one of the resource which is now available in bottles, and probably in future again. I feel, although we do have the canisters, oxygen canisters are there when you go to Leh Ladakh. But those days are not far off when probably we will have, the way we are using mineral water, we will be having oxygen bottles so that we can breathe and survive. So those are the not the dreams. It's happening now. The climate change is happening, and we are the generation probably who will be responsible for restoration, and we will be responsible for future generation as well, because of the rise of water level in ocean. Some of the islands are getting drowned. And probably some of the islands, some of the countries, if it is not being checked in, will extinguish, will not exist. Their existence is at stake. And the another crisis with which we are struggling, like, if you look up Dhanbad few years back, we never had any problem of water, drinking water. But right now, the way things are happening, probably it's very difficult. In CSIR-CIMFR itself, we used to give 2 times water supply. Now it is only 1 time, and we have been asked in to be very careful while while utilizing the water. So you need to be a bit careful about it. Similarly, if you look up apart from water, the soil degradation is another very important aspect, which need to be taken care of. Soil has been degraded like anything, and the exploitation of the soil or the agricultural land is another big concern for all of us. And Mother Nature, when we say it's Mother Nature in or the uh, we always refer Prithvi as uh, mother or as Ma. Why do we say in our culture uh, Dharti Ma? We have been saying as Dharti Ma, while land or the earth is being considered as a planet. But if you really look up planet or the earth, why we say it as Ma? Because it has life. Why has it got life? The planet Earth, it has got motion. It is not stationary. If it becomes stationary, we all will die. Second is it has got the warmth. It has got magma. It has got volcanic eruptions. So whenever it becomes furious, it has got magmatic eruptions. And it is Mother Earth which provides us water, which provides us food. So like Mother, it takes care of the humankind and all living organisms which are there on Earth, and which was there in our culture, in our society. But now globally people have started realizing it. And the ecosystem, the importance of ecosystem, or the planetary crisis with which we are going right now is being recognized by the global community, by the scientific community. And the crisis of biodiversity loss, which is there because of the various activities, including the desertification, crisis of climate change, and pollution and waste. These are few of the greatest challenges of our time, and this is the right time when as scientific community we need to think about it. We need to come up with some of the solutions. Sir, I would like to know, we would like you to know that we have developed one liquid tree, which is made up of algae and water, and this can be put up anywhere in a closed room, and is capable of providing oxygen and absorbing CO2. So this can be put up inside the airport, inside the railway station, and so many scientific interventions are required to tackle in the problem with which we are passing through for our future generation. And we'll also ask to Sanjay Singh sir, we have got a department or a research division, which is the environment division, which deals with the water resources management, water, land, and soil. To take up one small project wherein we can do some scientific intervention to providing the potable water to the society by utilizing the mine waste water. Something we can discuss about. So this is the right time, and we need to think about talks. Enough of talks have been done. In every conference, in every workshop, now and then we do hear about the sustainability and environmental challenges, opportunities, and in every conference some resolution is being taken up. But apart from all those resolutions, I think this is the right time when we need to think what we can do, what can I contribute, I as an individual, how can I contribute in checking the issues, the concerns which are there so far as environmental climate change is there. So under that, you like the energy literate one program was there. You need to be an energy literate. So when you are not utilizing your fan or ACs or bulbs, we need to put it off. So how many of us are really energy literate. We need to think about that. Similar is the scenario about water literate, how we are literate enough to save the water. So if we are not utilize, if it is not required, are we still using the water? So those are, small steps, but probably each and every one of us will be required to look up what can I contribute, and so that the impact on the environment can be reduced. So with these words, once again, I thank you all, and I warmly welcome to our honorable chief guest and guest of honor and all of you. Thank you. Thank you very much.
Thank you, sir, for your enlightening words and continued guidance. अब मैं डॉक्टर जेके पांडे सर, चीफ साइंटिस्ट एंड हेड पीपीआईआई से अनुरोध करती हूँ कृपया हमारे गेस्ट ऑफ ऑनर श्री संजय सिंह सर का संक्षिप्त परिचय प्रस्तुत करें।
धन्यवाद पुलवी। Respected chief guest of the today's function, Sri Prabhat Kumar ji, Director DGMS, Director Technical, Sri Sanjay Singh ji, today's chief guest of honor of today's function, Mr. A.K. Mishra, our director, Sujit Mandal ji, my dear colleagues in the hall and also present on the online. ये आज का एक सुखद संयोग है कि आज के हमारे दोनों गेस्ट इस प्रोग्राम के धनबाद के हैं, दोनों वेटरन माइनिंग इंजीनियर्स हैं, वन रिप्रेजेंटिंग इंडस्ट्री एंड अनदर रेगुलेटर, बोथ ऑफ देम हैव कम टू ए रिसर्च इंस्टीट्यूट। और ये तीनों मिलकर ही आपका संपूर्ण होते हैं। अगर हमको माइनिंग इंडस्ट्री को पर्याहितैषी या पर्यावरण फ्रेंडली बनाना है, सेफ बनाना है, तो इन तीनों के जरूरी है। एनीवन जब तक इंडस्ट्री के साथ रिसर्च और रेगुलेटर दोनों जुड़ेंगे नहीं, दिस कैन नॉट बी। सो दिस इज अ वेरी रेयर एंड वेरी प्लीजेंट occasion when we are going to listen both of them in the same program. And we all know, since both of them are from here only, we all know, but just as a customary, I am reading out the biodata of our guest of honor, Sri Sanjay Singh ji. Sanjay Singh ji is Director Technical of Bharat Coking Coal Limited since October 2023. He is a graduate from Indian School of Mines in 1991 and has a very illustrative career of 32 years in mining operation and brownfield and greenfield projects. He started his career in Tata Steel as graduate trainee in 1991 and worked over 28 years and finally reached to a general manager of the Tata Steel. He also worked as Adani Enterprises Limited as vice president for Sarguja cluster of the coal mines. He has worked in JSW as senior vice president of coal strategy. He is also a life member of the Mining Geology and Metallurgical Institute (MGMI). He has a vast experience of operating large open cast mines and underground coal mines. Sir, we are happy to be here in this our program, and we are enlightened to listen to you, sir.
Thank you, sir. May I now request our esteemed guest of honor, Shri Sanjay Kumar Singh sir, to kindly share his insights with us.
Chief guest of the function, Sri Prabhat Kumar sir, Director General DGMS, Director CIMFR, eminent scientist on the dais, scientist in front of dais, ladies, gentlemen, and I'm very happy to note that some young boys and girls are also there. So it's a matter of fact that we are quite concerned about our future, about the environment. So we wish to get them involved at a very early stage. That's a very hard that's a very good initiative. Good afternoon to one and all. It is really a profound honor to be here today on Environment Day, World Environment Day. The theme of the year this year, World Environment Day, is focus on land restoration, stopping desertification, and building drought resilience. You must have got the news that the highest recorded temperature in recent past in our capital, New Delhi, was 52.3 degrees centigrade. I don't know. There is a lot of debate that sensor was wrong or really temperature was there or not, but it was recorded. It was on 29th of May, which broke the record of 51 degrees Celsius recorded in Rajasthan in 2016. At this juncture, we are not sure how many more records will be made in coming years. This is happening at an alarming pace. What if such level of temperature sustains over a long period? We cannot comment on this, but yes, we can introspect today what went wrong and what are the things we are still doing wrong. The climate change is real, and the important thing is at this moment is to at least arrest the more degradation, if not the improvement. So being in coal industry for past 33 years and seeing its contribution towards transforming lives of people by providing them energy security, I can say even with the level of technology advancement available in the modern era, we cannot live without coal, not at least for next 2 to 3 decades. What can happen in future is a different story altogether. The burning coal has carbon footprint, that is one aspect, but in producing coal there is also a carbon footprint. So far being the coal producer itself, the burning of coal is not in our hand, which is a completely depend on market driven demand. But yes, the carbon footprint associated with the production of coal is something which can be countered with some available technologies, and some can be countered with the contribution of research community, with development of new method of technology. At least we can reduce the emission and absorb some of our emissions. Let me discuss first that what we are already doing to reduce emission. We are focusing on improving coal production and its washing to enhance the quality. So how it is helping to reduce emission? The increased coal production is countering the coal imports, and in the coming few years we hope to bring the import of at least thermal coal to zero. The reduced import will reduce the burden on shipping industry, which is a major contributor to the emissions. On the other hand, if we wash the coal, it will also reduce the burden on the transport sector by eliminating the transportation of non-carbon or rejects associated with the coal at the source plant itself. Now talking about four key areas where the immediate intervention can contribute to reduce and absorb the emission. Here the scientific community will play an important role by development of new method and technology. It is an area where industries are resilient to adopt the technology due to high capital infusion and less reliability. The scientific community can bridge this gap. This area of research won't be altogether new, but I feel less explored one. This area will not only help to mitigate our problem, but will also open new avenues of economics and finance. The first thing which I think is important is the use of electrical energy in the mining operation are only limited to large soil drag lines which have limited mobility in terms of operation at different sites. A huge volume of petroleum fuels is used to power our machineries. So the focus area here is to explore the possibility to expand the use of electrical energy, be it direct or through storage battery, into equipment like trucks, dumpers, and other HEMMs. Secondly, using the electrical electric machine is not only sufficient unless the source of electricity is renewable one. We are already utilizing our unutilized land to install large-scale solar parks. My request to scientific community to develop ways to explore the way to increase the efficiency. If we can improve only by 1%, it will be a significant step in this direction. Then I must admit we have a way to combat greenhouse gases, not just by reducing the emission, but by absorbing it. The reclamation of land after mining operation is an integral part. Even though we are able to reclaim the landscape up to some extent, but restoring even vegetation on those reclaimed area is a nightmare. Forget the forestation. This area needs research and development to innovate development of innovative methods and practices which can really help to restore vegetation and forest. This step will help to create carbon sink that offset our environmental impact. However, this endeavor requires concentrated research and innovative practices, as restoring ecosystem is not merely a regular obligation but a moral importance also. Then the last one, can we explore to install the solar park on the completed overwhelmed dams? Installing solar park require huge capital investment and it won't be sustainable for any industry to invest in something which is not sustainable or stable. As such, the scientific community can help us to find the way to install a stable solar park which are stable for good 20-30 years of time. At last, as we reflect on the theme Our Land, Our Future, we are hashtag Generation Restoration. It's a really, somebody can feel that this is a burden on us. Somebody can feel that this is our responsibility because we are Generation Restoration. It means in past we have not taken a good care of our earth or environment. And we are at a stage where we are concerned and we wish to hand over a better world to our next generation. So it's our obligation, responsibility, and moral responsibility to work in this direction. It is clear that the coal industry must evolve to meet the environmental challenge of our time. Now, government policies, technology innovations, and the dedication of organizations like CSIR, CIMFR, we can transform the coal industry into the pillar of sustainable development. We are on our journey to net zero by 2070, which is a collective endeavor requiring the commitment and collaboration of all stakeholders. Let us embrace this challenge with resolve and optimism, knowing that our effort today will shape a healthier, more sustainable future for generations to come. Let me conclude with a Hindi saying, we need to change. हमें बदलना ही होगा. यदि बदलने के तीन स्थिति हैं. आप स्वभाव से बदल जाए, स्वभाव से नहीं बदलेंगे तो अभाव से बदलना होगा. यदि अभाव से भी नहीं बदलेंगे तब दबाव में आके बदलना होगा. बेहतर है दबाव में आने के पहले ही हम लोग बदल जाए और अपने आने वाले जनरेशन को एक अच्छी दुनिया दे के जाए. थैंक यू, धन्यवाद. जय हिंद.
Thank you, sir, for your thought provoking talk. Your emphasis on sustainable practices and innovative approaches to land restoration has given us valuable insights and will undoubtedly guide us in our future efforts in achieving environmental sustainability. May I now request Jackie Pandey, sir, once again to kindly come to the podium and introduce our chief guest, Dr. Prabhat Kumar, sir.
Thank you, Pallavi. Respected guests on the dais and the colleagues off the dais and those who are connected online and also the small kids which are there present in the hall. As I have already told you, today's guest are very well known to us. They are among us. They are from very close to us physically as well as connect wise. So, uh, as a customary, just I am reading out his brief biodata to introduce him. Although, as I told him, he does not require any introduction. The Sri Prabhat Kumar ji is a graduate from NIT Rourkela in 1986 in mining engineering. He has vast experience of mining of industry as well as as a regulator in Director General of Mine Safety over last 25 more than 25 years. He has also worked in different capacities in DGMS, also Deputy Director General of Mine Safety of Headquarters, and then finally he joined as Director General of Mine Safety in 2023, and since then he is guiding the mining industry as a Director General of Mine Safety. As before, without missing the time, without any, I don't want to saying anything, and because I was sitting with DG Saab just in director's chamber for 5 minute interaction, he gave us 2-3 food for thought and problems to work. So without wasting any time, I like to request him to come address and give us some problems to make our mines safe and more sustainable and environmentally. Thank you.
Thank you. My friends on the dais, Dr. Mishra, Sri Sanjay Kumar Singh, Dr. Pandey, Dr. Mandal, friends of the dais, eminent scientists, respected ladies and children. Today we are celebrating World Environment Day. This we started long back in some 72 and 74, and continuously we are celebrating. But what we see in the field, we are going on celebrating Environment Day, and environment is continuously degrading. So what is the cause? When we are very serious about protecting the environment, why it is degrading? Means our demand is so high, we are not able to do justice with the environment. Friends, I have traveled throughout India, even interior parts. Many places we have seen, many places persons are not concerned with environment anything anymore. I have seen there are few plants, and when time comes they cut the plants. Not they are very needed. It is needed to cut the plants. Even without thinking something, they cut the plant. So this is what there in our society. We are not serious, or we are not knowledgeable about the environment. Even when we were child, when we used to study in class 3, 4, 5, 6, 7, this environment it was not taught to us. Now it is in the curriculum. So children are not aware of the now environment. So when we are kids, we are not aware of all those things, how to protect the environment, why it is necessary, why it is needed. And by that time, it was also not much necessary, because we were not used to destroy the environment or destroy the soil or anything like that. Even today also, when you go to some backward community, there will not find persons destroying the environment. So this destruction of environment, it has come with the development or urbanization. What is the solution? So we are yet to get the solution. Because if we have got some solution, there must have been some improvement. In mining field, we find some improvement because wherever there are mines, this afforestation has been done and environment has been being better and better. We are making it better and better. But other fields you will find as such. Uh, since I told you, I have traveled long, very depth to the interior areas of the even villages and countryside. In Rajasthan, I have seen. Uh, if you travel for 100 kilometers, you will find one patch, one greenery is there. Otherwise, again, same deserted area. Even there, I have found some plants are there, trees are there. People don't hesitate to cut the trees. So this is our concern. How we can protect the environment? How we can do better for the environment protection? Two ways are there. Whatever damage has been done, restore it. We are generation restoration, what we call, because we have destroyed so much that we should feel the responsibility that we have to restore it. Second is don't damage the environment. So this second one is the first, don't disturb the environment. Why to disturb the environment if we can do without disturbing it? If you go towards forests, throughout the road to the forest, the afforestation or say forest density you will find very less, even on hills also. If you had been to hills some 20-25 years back and you go now to the hills, high hills, you will find that this density of forestation is reduced. Now, how it can happen? When there is no access to the forest, then why? Then we don't have such concerns not to cut the trees. Why we cut the trees? For some money only. There are substitutes. Why you are not doing that? So these are the concerns. We know what is the problem. We also know what is the solution. Then why you are not doing? So there is something mismatch, the problem and the solution. So here comes our role. The role of the educated persons, role of the scientific institutions, how to match this one. How to ask our people, you can do without this also. But it is not as required, it is not being done. What is the pollution? We are noise pollution. You will find in many ceremonies in the night by 12 o'clock, 1 o'clock, there is very loud music is being played. This is also pollution. Dust pollution is there. Then we say even some places light, it's a very high beam are being produced. This is also pollution. So many types of pollutions. But the pollution which is concerned to us is basic one. We need our good land, water. These are the things, resources. Many places we don't get sufficient sunlight. So that also comes under the category of pollution. Don't get sunlight, sufficient sunlight, good quality of sunlight. These days, due to pollution, sufficient sunlight is not coming on the ground. Ultraviolet rays are coming and the required things are not coming. So these are the problems we are finding. We are not getting solution. Here is the role of the scientific institutions and the persons who know about environment, how to do, how to protect. Rest, what others can do, what persons who are not aware of many things can do, don't disturb the environment. Don't waste water, don't waste electricity. Only the required things you have to do. Use the abundantly available sunlight and something like these things. So these small things will make big changes. So we have to change. Restore means we have to change ourselves to restore the environment, to restore the earth. In mining areas also, you'll find that the urbanization in mining areas, it is very clumsy. Houses will be built in such a way that the drainage will be not there, proper drainage will not be there. In rainwater will go down to river and again to sea or something like that. We are not able to store water. As Mishra Sahib was telling, there is the problem of drinking water in Dhanbad. Why it should be? There is sufficient rainwater. Why there is problem? So we are not aware of how to do the things in better way. That why the problem is there. Why drainage of this groundwater so much? Everywhere will put the boreholes and drain the water. That is also environmental concern. So if groundwater is not there, the soil will deteriorate and it will not support the afforestation. This is also there. So that knowledge you have to get. So this should be rightly now it is being taught in the primary classes, but it should come to the knowledge of every person. It is not coming. So concerted effort is required. The general person, general people, what they can do, that should be there what they can do. And what they are not able to do, the educational institutes, the research institutes, government functionaries, they have to do. So that concerted effort will be able to restore the environment. So generation restoration, if we feel the responsibility, if we are generation restoration, we will be able to do it. But to feel it is very difficult. Why? What will do? I have not done these bad things, but another there is another few other things. What small things are doing? Does it affect? Does it destroy the environment? It is affecting the environment. It is affecting the ecology, or the industrial things, the big industries, big other countries who are doing many other things which are destroying the environment. This glaciers are going back and back. It is melting. Now, why it is happening? Is it happening because we are cutting the trees, or it is happening due to some other reasons? We are not very much clear. At least I am not clear. Many things are happening. Why it is happening? So the our efforts should be in the right direction where we can achieve the result. It is not like that we will ask many persons do come on the road, do plantation, do cleaning and all those things. But if its effort will give some 10%, 5% result. But we should concentrate on the ways which will give us higher and higher results. So what are those ways? So the persons who are making some research on those things, they will only be tell us what is the main idea behind all those things, or what the 1, 2, 3, 4, if you prioritize the task, which task is needed most. If some product, industrial product, it is hampering the environment in a big way. If we stop the production of that particular item, if it improves the environment by 10%, say 10%, 15%, why we should not do that? That is also to be thought of. So it's not that few persons can do that or all persons combinedly can make it. It is not there. We need some technology, technological innovation, technological intervention, and all those things. So here the role comes of our eminent scientists in mining areas, especially by you people, because you are the research base of mining area. On based on your research only, these all the mine operators, they work. We have seen other institutions also, even IIT Mumbai, they are also involved. Kharagpur IIT, they are also involved. Many institutions are involved. But what I feel, the result we get from CIMFR research and CIMFR's intervention, that is far better than others. So your role is much bigger over here because you are concerned with mining, and here whoever is there, all the stakeholders belong to the mining industry. So it is very big role, and you have to come up. That's why Dr. Pandey was talking about. We had talked 1, 2 things. We are talking about this since last 20, 25 years, even more than that. But we are not able to come up with a good solution. Why you are not able to come up? Because it is not easy task. So it is not easy. That's why we are not able to come up with a solution. We have to think about that. And serious thinking, we'll be able to get something. So we all start with the motto, uh, our land, our future. We are generation restoration. So get some responsibility. You should build some responsibility on this theme and try to do whatever you can do. Rest, the bigger things, let big people do. The government institutions, the research institutions, let good these people do. The small things what we can do, let us do. This plantation, it's don't waste water, don't contaminate the air, don't contaminate the water, and all those things. With the water harvesting and all the small things what we can do, let us do. It will make some difference, and these small differences will make big difference in our life. Maybe after say 20, 25 years, 30 years, next generation will be able to say, no, our fathers, the earlier generations, they were quite sensitive, and we may get some words of thanks from them. That will be a very big achievement for us. We should hope for that. So I wish you all the best on this occasion, and for us also, we can do something better for the safety of the people by protecting environment and saving soil. We have many movements. Save soil movement is also there. Save water movement is also there. Save air movement is also there. Let wish success to all such movements. So on this note, to get better and better environment for us, for our next generations, I thank you all for inviting me and giving attention and listening to me. Thank you very much.
Thank you so much, sir, for your enlightening speech. Your detailed analysis of the current environmental challenges and the presenting of actionable solutions that you proposed have greatly enriched our understanding. And your emphasis on integrating sustainable practices in our work to build a resilient future for our land and resources is inspiring for us. Now, ladies and gentlemen, there is a slight change of plans, which I'll be announcing shortly. Um, Now, in order to express our extreme gratitude for sparing a valuable time, sir, I kindly request Director, sir, to felicitate our guest of honor and chief guest, with a memento and shawl. एक्चुअली वर्चुअल स्पीकर ज्वाइन हो गए, उनको वेलकम कर दीजिए सर, स्टार्ट हो जाएगा और फिर I'll announce. Okay. Now, ladies and gentlemen, we move to the online talks. Before we begin the online lectures, may I kindly request Director Sir to welcome the eminent personalities joined online with us by presenting a book, but it will be a virtual welcome. I request the volunteers to bring the book. Yes, I'll be announcing. Yeah, I'll be reading out. So may I now request Director Sir to welcome Santosh Kumar Singh sir from Adani Power, and also Professor A.P. Dimri sir. Introducing Santosh Kumar Singh sir, Head of Adani Energy Sustainability, and Professor A.P. Dimri. Thank you, sir. We are very grateful to have both of you with us. So we'll move on to the first invited online talk. And for that, before we begin the talk, I would like to invite my colleague, Dr. Sudarshan Singh Rathore, to introduce Shri Santosh Kumar Singh, sir, Head of Energy Sustainability Group at Adani Power.
Thank you, Dr. Pallavi. I'm delighted to introduce Mr. Santosh Kumar Singh. He is the head of Adani Energy Sustainable Group. He is the Chief Sustainability Officer for Green Energy Limited, Adani Energy Solution Limited, and Adani Power Limited. He is responsible for the driving sustainability initiative across national and international forums for the sustainability and climate change. He is graduate from the ITSM in 1991, and he is the colleague of our guest of honor today's Mr. Sanjay Kumar Singh. He's postgraduate from the Indian Institute of Forest Management in 1998. He's having more than 30-year experience in environment and social studies, driving sustainability initiatives, enterprises risk management, and ESG reporting and the project development. He is having extensive experience in the ESIA studies as per the IFS performance standards. He is providing key inputs for the green loan and framework for the green financing and sustainability link bonding. With this brief introduction, I would like to request Mr. Singh to start his lecture. Thank you.
Yeah, thanks. Thanks for the introduction. And I take this opportunity to address all of you. It's an honor. I would have loved to be there in person, but I could not travel to Dhanbad and opted to join online. First of all, my regards to Professor Mishra, Chief Guest Mr. Prabhat Kumar, and a very good friend of mine, Sanjay. And before I start, there are a lot of discussion on climate change, pollution, and the ways of life in which we can address those issues at the corporate level, at the society level, also at the individual level. But the message is very clear. What the Secretary General of the United States, United Nations also said that we are generation restoration. If we are not able to deliver, maybe the humanity will be beyond the point of return. So that's a message which has been reiterated by all the speakers. And my expertise or my experience of working in this sector is slightly different. I've been working in the energy sector for the last 2 decades and on sustainability for the last 15 years. I'll focus on that, how energy transition is happening or is likely to happen. And I've seen the full cycle, especially in the country, which started perhaps with the Electricity Act reforms in 2003, when everybody wanted to put up a coal-based thermal power plant.
You're muted. So you're muted.
Oh, I'm sorry.
Yeah, it's all right.
Sorry.
Yeah, it's fine.
Maybe I should begin again. So, first of all, my gratitude and thanks to have me online. I would have loved to be there in person, but this is the second best way of communicating what we can. So, first of all, I am Santosh Kumar Singh. I head Adani Energy Sustainability Group, working in energy sector for the last 2 decades and on energy transition and sustainability for the last 15 years. So that's the area I've been working on, energy transition, and that is what I'll speak about. There are a lot of speakers who focused on climate change and the unsustainable growth that we have been having, and how it has impacted us, how it has impacted the climate, the environment, the sea levels, and also the weather pattern. So, and all the speakers also made a mention that we are the generation restoration. The whole idea of the Secretary General United Nations taking this cause was that if our generation does not do it, maybe the humanity will go beyond the point of return. So that is the stage that we are in, having seen the first industrial revolution, second industrial revolution, and maybe the third one also. We have come to a point where it is not only urgently to be addressed, but maybe we have consumed more than whatever the carbon quota that we had. So I'll just explain what do we understand by energy transition. Basically, it means that shift of focus from traditional fossil fuels to renewable energy sources, which not only reduces pollution but also reduces greenhouse gas emission, mitigates climate change, and can promote sustainable development. When I talk in the Indian context, where we are the largest and most populous country in the world, and also one of the fastest growing larger economies, so the responsibility is immense because the demand growth is like happening like anything. Every year we see a new record. In 2023, we saw the grid demand of 243 gigawatt. In 2024, it has already crossed 250 gigawatt, and this is only going to increase. And if I talk about the energy landscape that we have, give me a sec. Yeah, I'm sorry. So I was talking about the energy mix or the energy scenario of the country. So we are the third largest energy consumer in the world, and our energy mix has been dominated by coal, contributing more than 70% of our electricity generation. However, over the last decade, there have been a lot of push towards renewable energy, and India as a country is leading the renewable energy drive. And as we speak today, India stands fourth in terms of renewable energy installed capacity when we include small hydro as well as large hydro. Because that was the international concept. India for a very long time did not include large hydro into renewables, but now we have started doing it. We are fourth in wind power installed capacity, fifth in solar power generation capacity, and one of the most ambitious target of reaching 500 gigawatt of renewables by 2030, and to meet more than 50% of the energy from non-fossil fuel sources. And if we talk of each and every sector, so the solar drive maybe started in 2010 by the National Solar Mission, and today the solar capacity of the country is about 82 gigawatt, and year on year we are targeting, we have been adding close to 10 gigawatt in the last 3 years. On wind side, the progress has tapered off, but still we have almost 46 gigawatt of capacity. But wind again is based on the availability and mainly in the states of Tamil Nadu, Gujarat, Rajasthan, and Karnataka. The other sources like hydro and biomass, we have close to 50 gigawatt of hydro and 11 gigawatt of biomass. So in terms of installed capacity, we are at about 43% of the capacity is from non-fossil fuel based sources. But the scenario comes or is very different when we come to the generation side, where most of the renewables have very low capacity utilization factor compared to fossil fuel sources. So in the last financial year, 23-24, the generation or the actual generation consumed by the grid was 76.26% from the thermal. So that's the scenario where we are in. And as a country trying to transition from fossil fuel to non-fossil fuel, there has been a lot of focus on policy and regulatory changes, mainly started with National Action Plan on climate change and introduction of RPOs, that is renewable power obligation for the discoms, and then gradually shifting to liability gap funding and then PLI schemes for manufacture within the country. And recently there have been a lot of domestic content requirement for putting solar power plant. That this is what has enabled us to reach the scale that where we are. And there are again a lot of policy initiatives and development happening in terms of green hydrogen, essentially hydrogen generated from renewable energy sources. Then storage solutions, because renewable sources are intermittent in nature. And then there is now an initiative on offshore wind. In addition to climate change, there are a lot of economic and social benefits that are expected from this energy transition or shift of energy from fossil fuel to renewables. What it essentially does is, in addition to having reducing the social impact or the impact of fossil fuel that happens on the society, it also brings a lot of economic and social benefits in terms of jobs, energy security, as well as reducing our dependence on imported fuels. Because we all know India as a country is net importer of energy. So that's one area where we will definitely overcome it. I'll explain how we have done at Adani in terms of helping the energy transition or being part of the energy transition story. Right from the beginning, we were very conscious of putting very efficient boilers for fossil fuel-based generation. Out of the 15 gigawatt capacity that we have, almost 76% are based on critical and ultra supercritical capacity. And as an organization, we have now decided that all new capacity that we add will be based on ultra supercritical only, which essentially reduces the specific consumption of coal and water. In addition, we have a huge renewable program. We have almost 11 gigawatt of renewable capacity already connected to the grid, and we target to be a 50 gigawatt renewable capacity company by 2015. To address the storage part, that is due to intermittency of renewable, uh, the solution that we are looking for is pump storage. It's a low-cost solution and grid-level solution. We already have started our 500 megawatt first storage capacity construction in Andhra Pradesh, and we have almost 10 gigawatt under different stages of development. Now, for fossil fuel based plant, we always had an option of putting that station near the pithead or near the load center. But for renewables, that option is not there. We have to put them wherever the resource is. So all those renewable power stations which are coming up are in the remote location, maybe the western part of Rajasthan or the desert part of Rajasthan, then Kutch area of Gujarat, where there is not much of load. So another challenge that it creates is transmission of bulk renewable power, where construction of green corridors for evacuation of bulk RE power is required. So that is an area where we have been working on. We have almost 18 transmission system of 400 kV and 765 kV built for evacuation of renewable energy. And then we have also worked on the distribution part. We are a distribution licensee for the city of Mumbai. We took a target of having more and more renewable to be distributed in the city of Mumbai. And as we speak today, Mumbai receives almost 38% of its power from renewable sources. And we have a target of scaling it up to 70% by the year 2030. Now, during the entire process, we have faced many challenges which any energy transition project or any company addressing energy transition has been facing. Some of the challenges I will just mention, maybe 3 or 4 of them. First one is the grid integration because of the intermittency, where for coal-based thermal power plant, we used to have an N-1 configuration that if one circuit is out, still the transmission should be able to transmit the power or evacuate the power. But with renewable, perhaps we are looking at more stability, and maybe N-2 configuration is what we should look at. And then it puts a lot of pressure in terms of advanced grid management and energy storage solutions to have the stability of the grid. The second biggest challenge is the finance. Globally, I believe the world requires almost 4.5 trillion per year in US dollar per year till 2030 to address climate change. The Ministry of Renewable Energy, India has estimated that India will need close to 1.5 lakh to 2 lakh crore of investment year on year only on the generation side. And if we see the transmission and distribution side, maybe it will add 15 to 20% more. So that's the kind of challenge we have. The third challenge being energy company we have faced with the policy inconsistency. Although the direction is clear, but there have been a lot of flip-flop in terms of import restrictions, then domestic content requirement, then viability gap funding and the mechanism how it will work. And maybe the fourth one is again because solar needs a lot of land. When we started, it used to be about 4 acres per megawatt. As on today, it's close to 2.5 acres per megawatt. But still, availability of land and resources water for cleaning. They are also very critical and a major challenge. But despite all those challenges, a lot of advancements have taken place. First, it was driven by the technological advancement, because when we were doing our first solar project, maybe a 2 square meter panel used to give 100-watt peak. But now in 2024, the same area, the 2 square meter panel gives us about 630-watt peak. So that's the kind of technological advancement we have received in terms of, or we have undergone in terms of solar. For wind, maybe the wind turbine, that first wind turbine we used to put was 500 kilowatt. Now, in 2024, we are putting one turbine of 5.2 megawatt. So that's the kind of advancement it has taken place. I'll also just briefly touch upon two success stories that come to my mind and how it can change the renewable or the energy transition in the country. The first one is a very ambitious plan of Government of India, that's the Khavda Renewable Park. It's a single park which is being developed for 30 gigawatt. With all the evacuation under planning, it will have 5 double circuits of 765 kV level. And perhaps once fully operational, it will be set a benchmark for affordable and renewable power in India, and maybe replace a lot of fossil fuel requirements on the grid. The second one is the wind story of Tamil Nadu, because Tamil Nadu coast has a lot of wind potential and it is perhaps almost optimized now. And the way Tamil Nadu was able to integrate the wind power into the grid and address the stability of the grid is commendable. So that's one success story that we definitely have. And going forward, with our commitment to the Paris Agreement and active participation in different levels, such as Solar Alliance, we have been sharing a lot of knowledge, technology, and financial resources, which are viable for accelerating this transition. The path forward that I see is this needs further acceleration, and it is bound to happen because there was a lot of hesitation in investment till the time when solar and wind did not have the grid parity. But as on today, both solar as well as wind both have grid parity, and the cost of power from solar and wind sources is much less than any new fossil fuel-based generation. Policy and regulation still need to be streamlined and ironed out. And of course, the institutes and we have been working with a lot of IITs for R&D in grid stability, for EV development, monocrystalline as well as polycrystalline, and then monofacial as well as bifacial. And focus on energy efficiency is again another way of addressing this issue. And last but not the least, which Professor also touched about, is community awareness, community engagement. Because unless until we as a community are empowered to take those decisions and are able to take those decisions, climate change, perhaps addressing climate change will be a distant dream. So with that, I'll end my speech. And once again, many thanks to all of you.
Thank you, sir, for your informative speech. Your expertise in energy sustainability and the innovative initiatives you have undertaken at Adani Power are truly commendable. Your insights into integrating sustainable practices in the energy sector have given us valuable ideas that we can incorporate in our own projects, contributing to a greener and more sustainable future. Ladies and gentlemen, I please request a loud round of applause from all of you. Now, we move on to our next speaker, a person with countless achievements and the humongous biodata, Professor A.P. Dimbri. Before, sir, we listen to you, I kindly request my colleague, Dr. Apurv Sinha Mahapatra, to formally introduce Professor A.P. Dimbri, sir, Director of the Indian Institute of Geomagnetism.
Thank you, Dr. Pallavi. I am extremely privileged and honored to get the opportunity to introduce Professor Ashok Priyadarshan Dimri, the Director of the Indian Institute of Geomagnetism, Mumbai. He is a professor at the School of Environmental Science, JNU, New Delhi. He also serves as a concurrent faculty at the School Engineering, JNU. His accomplishments are so massive that It will take hours of time to describe. We are also running behind of our time schedule of this program. So in brief, Professor Bimri holds a PhD in atmospheric science from the Indian Institute of Technology, New Delhi in 2004, an MPhil in environmental science from JNU in 1994, in an MSc Tech in geophysics from Banaras Hindu University 1992, and a BSc honors in physics from BHU in 1989. His professional experience includes role as a scientist at the DRDO and various research positions in Japan, Germany, and UK. His research interests cover regional climate dynamics, climate modeling, climate change science, and the interaction of snow and glacier physics with the Himalayan climate. He was involved in the execution of several projects and received many prestigious awards. He has contributed more than 200 publications in the form of research articles, review articles, and book chapters. He is also fellow of NASI and FNA, along with many others. With this brief introduction, I would like to request Prof. Dimri to start his lecture. Sir, please.
Am I audible?
Yes, sir.
Okay, thank you for introducing me. Namaskar. Professor Mishra, thank you for inviting me for Environment Day. We have seen from last 1 decade that environment has become very, very critical and crucial. Few days back, we have seen temperatures touching 50 degrees Celsius in Delhi and some of other cities of our nation. Some part of Mumbai received delayed monsoon rainfall. I presently am in Mumbai. Environment this year is focused on land use changes, recycling of the waste, and so on and so forth. If you look at the traditional way of living, and earlier speakers has touched upon few points, sustainable development, living off the places. Land use, land cover have permanently changed from earlier decades now. Lot of concretization, buildings, constructions are adding to the environmental impacts and changes. Few examples, if we look at the land degradation, cities are growing, multi-towers are growing, and thus leading to dampen the surface wind, which in a way assists delayed cleaning of lower atmosphere pollutants, increase fog instability, and so on and so forth. A city which is supposed to be holding 1,000 people, for an example, is holding 10,000 of people, leading to overflow of the sewages, which is meant for less number of people, and hence the volume of flooding is there. We define it as urban flooding. It's not a conventional flooding because of the continuous rain which is coming over the region. So flooding because of the land use has increased in most of the places, be it Delhi, Mumbai, Chennai, and Himalayan region, Jammu and Kashmir, Ladakh. Thirdly, coming to the extremes, there are an enormous amount of precipitation happening in a very short amount of time, which otherwise was not possible. Forest fires, they have increased, their intensity has increased, leading to the drying. And not only that, there is a interaction of different crop, different agriculture is happening. Few of the examples are like pine is taking over oak. Pine grows in more dry atmosphere. I'm going solo because I can see that there's a problem of sharing the slides. So I don't want to waste time, and I'll speak extempore, and after some time I'll talk on the issues of the Himalayas. So every city is one way or another way is facing the environment problems. And I think CIMFR is one of the best institute which knows what are the environmental impacts in our country. If we are not looking for these kind of problems to adjust with growing population, with growing demand of energy, growing demand of the requirement, we will have a certain impact on the energy, food, water nexus. We very well remember the tropical cyclones in few decades back, which used to landfall in the coastal region of Bay of Bengal or Arabian Sea. They will used to decay. But in present time, these tropical cyclones not only intruding much inside the land, we have seen recent tropical cyclones gone much inside the tropical cyclone up to the Jharkhand, Bihar. Not only they intruded much inside the land, they are getting supply of the water because Arabian Sea, Bay of Bengal, as marine warming has taken place. And because of this marine warming, we have a lot of amount of energetics available for driving tropical cyclone much inland, not only driving, but adding a lot of the moisture as in supplement. In an Indian summer monsoon, which is a regional phenomena, due to this adjacent warming, has a different kind of pattern and it's moving westward. That's what you might have heard the floods in Banaskantha, Jodhpur, Jaisalmer during the monsoon time. And hence, it is not intruding much inside the northeast region. It's not getting locked, hooked in the Shillong plateau. Rather, it is riding over the Shillong plateau because it has a lot of energy available in driving when it propagates northward due to the differential heating of land and mass during pre-monsoon time. And that leads Indian summer monsoon to move further north, propagate in the much faster time. And hence, if these changes happens, it will have a changes in crop patterns, agriculture patterns. Particularly coming over the Himalayan region, if we look at that, this is a data sparse region. We have less amount of observations available over these regions, and we have very less amount of information available as far as observation of temperature and precipitation, or matter of fact, any other observation which is available for southern rim of Himalayas. Himalaya is a very beautiful massif, which geology people will tell me better. It came into the existence, started Himalayan origin, it started 55 million years back due to the plate tectonics. It started protruding. The protrusion was not very smooth. There was a lot of fault, cracks, and hence we see a lot of ranges within the Himalayas. And roughly 20 million years ago, Indian summer monsoon genesis has come because of the stopping the northward propagating moist rain by this Himalaya. And because rain has come and it started hitting the Himalayas, and it physically started eroding the sediment, and that's where we have the lower foothills of Shivaliks came into the existence. So much of the sediment has been taken out because of this physical hitting of the rain. And I would not mind saying that we do not have any observation beyond 3,000 meters for these kind of observations. So now Himalaya itself is a complex region. Land is on top of the Himalaya. You will see that they do not have much vegetation as we move 4,000 meter and southern flank of the Himalayas, or the Indian Himalayan region popularly called. Apart from that, they have a lot of variation when we go from Western Himalayan region to Northeast Himalayan region. And Himalaya not only impacts the Indian subcontinental regional weather and climate, it impacts global circulation, fluid flow across the globe, which is interpreted and interjected by Himalayas. And that's what we have a global teleconnection comes into the picture, how the Himalayas role is determined and defined, and coming on the land use, land cover over the Himalayan region, which interacts the above atmosphere, sensible heat flux, and so forth. So there is a different precipitation over this region. As I said, the northeast in future projection, we found that monsoon will not be arriving over this region, and hence mean precipitation by 2050 is going to be reduced over the Himalayan region, and most of the western Himalayan part will receive more amount of precipitation, and that's what we have seen. When I talk of the elevation dependent distribution of monsoonal precipitation and matter of fact of temperature, this is a kind of a conjugate fight happening in the upward propagating moist wind along the upslope of the Himalayas. It depends on how the buoyancy and gravity is taking place, and that will determine that how high Himalayan flow will go, and that will form the precipitation mechanism. Monsoon dynamics and precipitation are two different mechanisms. Moisture doesn't always precipitate. All the vertical available atmospheric moisture does not precipitate. Only certain amount of the moisture which gets in the formation of precipitation falls under gravity, and also buoyancy comes in the picture. If you have a convection, that raindrop will be pulled back into the free atmosphere. So it's a kind of a conjugate, or rather I would say resultant distribution of gravity and buoyancy, which will lead that how much amount of precipitation will be dumped at the receiving station. In the process, this rain will be coming across the warming environment, and if this warming environment is more, rain will dry, it will be evaporating, and hence that's very imperatively important for me to mention that if temperatures are increasing, your atmospheric column will be more warmer, and hence it will lead the precipitation to evaporate back and send back to the free atmosphere. So re-evaporation will occur, and rain will not be precipitated much in coming time over the Indian subcontinental region. Monsoon dynamics is entirely different from the classical fundamental distribution. If it happens so, we will be having deficit amount of precipitation. Linking with the extreme amount of precipitation, I know many of you have seen it, many of you have debated it. It is something like that. We have a sponge of washing utensils in everybody's kitchen, right? It is filled with the water within that. Earlier time, when the homogeneity of the atmosphere was existing, all the precipitation was trickling down homogeneously over the region. But in the present time, it's not happening. When you pin at one point, whole water trickling down at that particular point, and that's causing to the extreme. And present disaster management, when we are discussing, it's a very, very difficult to predict the extreme events. It's not at all predictable in the present global climate models to such a small scale at time as well as the space, lat long or XY, we call it very oftenly. So it's very, very difficult how to capture where the extreme is going to hit, and hence only available possibility is that how can we minimize the impact of the disaster over this region. And when I'm saying that, in vertical distribution of the atmosphere, we find that over the Himalayan region, higher elevations are receiving less amount of precipitation, and lower elevations where monsoon goes and interacts in the orographic forcing, orographic interaction, or orographic injections, that's where is the most of the precipitation is locked over this region. And hence, in view of that, we will see that how much amount of kind of precipitation is going to be implemented over the region. And if that happens, sorry, I'm rolling this slides at my end. And if this happens, then what is going to be impacted, that your distribution of the elevation dependent precipitation over the southern rim of the Indian Himalayan region will be very, very reversed. And hence, as I told before, pine is taking over oak. Oak has more moisture availability than pine, and hence, because of the drying of the atmosphere, pine is taking over oak. Impact is, pine is more prone to the burning. And hence, we have the increased dots of forest fires over the southern rim of Himalayas. However, interestingly, all this mechanism is primarily happening at 1,000-1,500 meters till 2,000 meters, because that is the more convective zone or across the Himalayas. Beyond that, we don't have much mechanism and physical processes happening, because monsoon rain cannot be lifted up slope that much, because it needs more amount of forcing, orographic forcing, to lift it up that elevation. And simultaneously, you need to have more moisture availability to be dumped over this region. If both the mechanism, orographic as well as precipitation forming mechanism, occur over the region, hence the precipitation will be happening. If this doesn't happen in like that manner, what is going to happen? Our snow line is going to recede down. Our vegetation line is going to recede down. If our vegetation is migrating, animal species has migrating, and this kind of trend, if keep going, possibly in future, the human migration will happen. We have the established classical examples of Mohenjo-daro. We have classical example of Dholavira. We have example of Harappa, where civilization resisted for very long time. Long famine forced them to die out, and even though they moved along the existing river of that time, but still they cannot continue, and a whole civilization has died, and there are enough studies available for their dying. Coming to temperature now, temperature all along is increasing. As IPCC projections, they have increased the temperatures increasing, and in fact in the 2015 Paris Protocol, it was decided that can we hold at 1.5 degree by the end of the century. But we'll see, we saw that just few days back, that as I told, that Delhi crossed 50 degrees centigrade. So within few years, Delhi has crossed 50 degrees centigrade. It has a regional implication also, in the sense that it's not simply that Delhi got some kind of more heat available over the region to increase the temperature. Simultaneously, it has a conjugate effect of the 2 years back Honga Tonga volcano eruption has taken place. The westward moving flow, warming flow, Rajasthan warming flow, has warmed up Delhi more because of the urban heat. Delhi itself is concretized now. So it will be very intuitive to see that Rajasthan region is having comparatively lesser temperature than Delhi. So that is very intriguing, that how the conjugate effect of various physical forcings due to the environmental impact is going to lead for these kind of events which are happening again and again and leading to the temperature rise over the region. In case of Himalaya, temperature rise is not homogeneous again, as I want to convey. Higher elevations warming rate, please, I remind, it's warming rate, not warming. Warming rate is more than the lower elevation of the Himalaya. Why? Because in the lower elevation, we have comparatively more amount of moisture available over the region than the higher Himalaya. Higher Himalaya is already drier because less amount of moisture or precipitation. For me, air and water is same. I just look up from the density flux point of view. Both are same, and higher elevation have less amount of precipitation, hence the temperature, which is increasing warming rate, is more free to move, whereas temperature in the moist region has a controlled moisture control cycle. Like in the monsoon time, temperature comes down because monsoon is holding the temperature not to fly off. It controls it down. So variability of the temperature and moisture over the region has a conjugate consistent trend comparatively than where is the dry area. So dry area is going to be more drier, and in due course of time, complete warming over the region will lead that the evaporation and available moisture will also take a very distinctly different role. And in different season, monsoon, pre-monsoon, post-monsoon, and winter, we found that post-monsoon is having more rise over the Himalayan region as compared to other seasons. We try to explain that why it's happening, what is the physical mechanism behind that over the region. We saw that the incoming solar radiation or the downwelling long wave radiation trend has increased, And these increased downwelling long wave radiation, particularly when it falls over the surface, could be having various coupled mechanism. And this coupled mechanism is leading to the increase the clouds, because your moisture is getting lifted up. When it lifts up in the free atmosphere vertically, it condenses, and that's where the cloud starts forming. We, in atmospheric science, base of the cloud we call the lifting condensation level. That's where cloud starts forming, where the available moisture start converting to the water or water vapor or mixed phase hydrometeors. So that's the one reason that cloud is roughly 3000 meter is increasing, and low level cloud is also kind of getting lifted more. When we say low level cloud, it is 2 kilometer base height clouds. So low clouds also are getting lifted up. So your atmosphere within the cloud base to the surface is also increasing. So the filling this atmosphere in the changing climate change pattern will be very, very difficult. Another important phenomena which we see in the winter time, of course, I'm not sure it reaches to Dhanbad or not, but this is the supplement for the important northern Indian rivers. Ganges passes through Dhanbad, so maybe this is important in the sense we call it western disturbances. We call it western disturbance because dense perturbation is somewhere west, and in large scale westerly it passes through winter time over the Indian subcontinent. It yields most of the amount of precipitation in the form of solid or mixed snow, mixed ice. So Indian summer monsoon and western disturbance precipitation distribution is entirely different. Indian summer monsoon comes at the lower level and climbs up, whereas Indian summer winter, the western disturbance comes roughly at 200 hectopascal and gives precipitation over this region. Now, intensity of this precipitation on winter time is very, very important because this supplements the spring melt to these rivers, and that's very, very important. If this system goes off, they are no more there, we will have less amount of river discharge, and this river discharge will be primarily because of the available of snow or cryosphere glacier mass as of now. But once that mass completely melts off, that's what we have seen by 2050 we will have a doubling of the discharge because of the increased temperature. But after 2050 the volume and amount of the mass available for supplementing this river flow will be getting minimized over this region. And simultaneously, we also saw that in recent time, WDs are no more yielding good amount of snowfall over the region. And that is one of the important talk on Karakoram anomaly, where many of the researchers, and I hope here people have heard that Karakoram glacier are either stable or they are growing. Balchura glacier, part of the Siachen glacier, Karakoram part, and we saw that though we don't have data from the modeling strategy, we have hypothesized, rather I would say, that why the Karakoram is growing, because Karakoram is growing, that whatever is the lifting condensation level over the Karakoram region is now exactly sitting where Karakoram is. Karakoram is roughly 6,000 meters. So whatever the small amount of moisture is coming over this region, it immediately gets dumped over the glacier, and that leads to the increased mass of the Karakoram in case of increasing its length or this glacier to be remain stable. So lower lifting condensation level will enhance the cloudiness condition over the region, because if you are lowering the lifting condensation level, cloudiness will also increase, and in a feedback mechanism, the outgoing radiation or incoming radiation will have a positive or negative feedback in that sense. And that balance will determine that in different season, in the summertime and winter time, how the cloud mechanism feedback will be resultant for the health of the Karakoram glacier per se. And that's what we found also, that Karakoram is not exactly following the climate change. Basically, they are cooling the skin temperature, not air temperature. The skin temperature of the Karakoram surface is decreasing. It's a kind of negative, I would say. Trend is negative. I would say last 30 years data shows that if trend is negative, so the snow mass, trend of snow surface amount in this 30 years is increasing over the Karakoram as compared to the adjacent other glacier in Ladakh region. And simultaneously, when there is a more amount of snow is increasing in any form, mixed phase, or the trend of surface upwelling shortwave radiation also shows that they are positive. So energy is also getting reflected back because of the colder temperatures. So in a way, this feedback mechanism fits very well, that even the energy is getting emitted back, your trend of surface upwelling long wave radiation is also negative, and hence this conjugate effect tells us that your Karakoram's physical mechanism or process leading to growth of this. Another interesting point which we saw in the upper Indus Basin, because of the monsoon is going forcing northward upward because of the increased warming of the oceanic body around this Indian peninsular region, and hence in last many years, almost 30 years data, we have simulated from 1970 to 2099, and based on this almost 130 years run, we found that lot of amount of water will be available in the upper Indus Basin riparian region. So more supplement of water will be available in the region, but in the lower riparian, which is presently Pakistan and part of Afghanistan, will be getting drier and drier because monsoon is not reaching there anymore. Another interesting factor, if you know the monsoon dynamics, by the time on the statistical average, robust statistical average, by 1st June in general, it is hits the onset, hits the Kerala coast. There's a plus minus some days, and by 10th June they split. Now Arabian Sea branch moves much faster because of the head bay of Arabian Sea is warmed much higher than the other rest of the bodies, and that is another reason that the Arabian Sea branch of the Indian summer monsoon is more propagating northward than the Bay of Bengal branch, which turns towards the Calcutta and then again turns towards left because of the orographic locking during the Khasi Jayantia hill, and in north we have Himalayan belt. Interestingly, we found in Kashmir Bowl, the temperature is reversed. It's not following the complete pattern as I told the warming rate. If you remember that higher elevation warming rate is more. In Kashmir Bowl, if you look the geomorphology of the Kashmir Bowl, we saw that the higher elevation warming rate is lesser than the valley floor of the Kashmir Bowl, because Kashmir Bowl is such that it doesn't interact with the upper atmosphere. It caps the interaction, vertical interaction of the atmospheric processes. And what happens that there is a lot of pollution due to the burning of coal, bukharis, cooking, so on and so forth. So it acts as a trapping mechanism within the valley, and then valley remains in another way than what we see in the complete Himalayan region. That is very interesting finding we saw, and similarly we have seen something in the eastern side of Uttarakhand region, where we saw that the Uttarakhand eastern side is becoming more warmer than the eastern side comparatively. Cloudburst is a very interesting phenomenon. Generally is not very well known because most of the cloudbursts which is reported are reported in the Indian Himalayan region when it hits the downstream population, and that is the time when cloudburst is reported over the region. And hence then we say that a lot of water is thrown over the higher Himalayan region, which under the revolute it comes down. Now there are two problems from the disaster point of view. In present time, a lot of land or construction has been made along the rivulets, which otherwise was the exits for this huge volume of water. In the river plain, in the flood region, we see that a lot of construction of individual villages or many people are there. In our Himalayan, from where I came, villages are always made from very far from such river or rivulets or small rivers. But now in the bank of river, a lot of construction has taken place. And what happens, even if there's a minor amount of disaster due to the cloudburst is happening, it blows off all these settlements, leading to the much amount of precipitation or damage to the cattle, property, human, so and so forth. Another disaster is the forest fire. If you look at the forest fire in these recent decades, we found that it has increased number of frequency over the region, and almost in last 10 years it's almost 10 times has increased over this region. And hazards has not been remain a kind of a singular hazard anymore. They are kind of a cascading hazard. I would like to say that in case of Chamoli disaster 2021, a small rock fall has occurred from the top hill, fallen roughly 3 kilometers and gone almost 10 degrees centigrade per kilometer warming. This rock might be having a kind of a permafrost which has melted because of this passage of warming, and it became melt. It has become a bit slippery, and few days back there is a good amount of snow has happened. It led to the microseismic tremors. The avalanche has come, and along with the avalanche mass, this whole mass started moving further down, and it became a kind of a dammed a small rivulet which came into the path, one Rotigard, and once this Rotigard broke this dam, or I should not say dam, it's a forced block of these things, it came to the NTPC tunnel in a slurry manner. So this is another important aspect. We say that this is the cascading hazards, we call it very popularly. The hazard is no more a singular hazard like heat wave. Of course, it needs a temperature increase, but how much above normal? Now it need these definitions also need to be redefined. That generally 4 days continuously above normal temperature anomaly is determined by the heat wave. Similarly, lightning, this is another threat happening in disaster. So they are all kind of critical factors in eco-hydrological functioning, micro level or macro level issues, emission of the various carbon dioxide. We saw in last decade from 412 ppm carbon dioxide emission has gone to roughly 421 point something ppmb. So how we can minimize these emissions which are adding to the free atmosphere, and based on these emissions which are limited, how we can think of the environmental control mechanism in one way or other. And in view of that, if we are talking of the environment, how can we plan for a sustainable development for the future generations? That remains a question, that remains an honest responsibility for us, that how environment, each year we are celebrating this in one way or other, how in a way we can use this knowledge which we have gained from various years research, and based on that various of research we can improve upon the environmental impacts, minimize the environmental impacts, and that is the owner's responsibility. So with this brief presentation, I will stop here, and if anybody has a question answer session, I'll be very happy to take few questions. Thank you very much for giving me this opportunity.
Thank you, sir. So, anybody in the audience, if anybody has any questions, please go ahead.
Sorry, I could not fix the presentation for larger audience, and I did not want to waste time, so I went solo, whatever I could speak. Thank you.
Thank you, sir. Anybody has any questions? Okay. Thank you, sir, for your enlightening speech and your extensive research on geomagnetism and its impact on our understanding of Earth's climate has provided us profound knowledge and new perspectives, and it will help us in our research as well. Thank you so much. And now I kindly request our director to felicitate our esteemed guests, albeit virtually. Yes, sir. Could you kindly come up to the dais? Can you turn the camera towards so wherever it's comfortable for you, sir. Okay. Where the camera is, so if you could come, I request the volunteers. So as a token of our gratitude, I request our director to present a shawl and a small memento, albeit virtually. Yes, and of course we'll be sending it by courier, of course.
As soon as we do virtually, it is being transmitted. Okay. So thank you very much, Professor Dimri.
Thank
Thanks a
you.
lot for sparing your valuable time and giving a wonderful talk. It was quite enlightening, at least for me, and I think for all of us who are present here. So thank you very much for your time. And I think we need to develop a technology wherein, virtually when we do felicitate, immediately it is being, transmitted and being received in. So maybe in
Thank
future
you.
we'll get in.
Yeah.
So thank you for being part of the program, and this what a small token of love and appreciation
Thank you
from
very
the
much.
institute. Thank you
Thank you
very
very
much.
much.
Applause, please. Thank you, sir. Now also to Shri Santosh Kumar Singh, sir, from Adani Power. I think he's not connected anymore, albeit we can felicitate him virtually and will deliver.
Okay, thank you.
Thank you, sir. Thank you to Professor A.P. Dimri and to Shri Santosh Kumar Singh for your valuable talks.
Thank you.
I can leave now.
Yes, sir. If you may.
Okay, thank you. Thank you for giving me this opportunity, Professor Mishra. And I hope that very soon we will have a personal meeting sometime. Thank you very much.
Thank you very much.
Now, yes, sir. Oh. Price distribution. Now we move on to one of the awaited segments of today's program, which is the distribution of the prizes for the various competitions that were held earlier this morning. So we start with announcing the results of the drawing competition. So when I call out your names, please step forward. I'll just announce the names so that they can come forward. And the volunteers, are you ready? So I request the dignitaries to kindly come to the front of the podium. So the first prize goes to Mr. Niladri Sadhu Khan. He's in Standard 6 from DPS and he's the son of Bishwajit Sadhu Khan. Is he here? Yes, he's here. The second prize goes to Mr. Tanish Mohanty, Standard 6 DPS. He's the son of Professor Dibdatta Mohanty. For the third prize, we have two joint winners, Mr. Kushagra Ranjan from Standard 7 Dinobli School. He is the son of Dr. Ranjan Kumar, and Miss Arohi Jaiswal, Standard 6 Dinobli School, CMRI. She is the daughter of Mr. Amit Jaiswal. Can we have both the winners? Astidva is coming to collect the prize for her sister. Next, we have the results of the essay competition. So, for the essay competition, there were two groups. The students were divided into two groups. The first group is students from class 9th and 10th standard, and the second group is for the students from standard 11th and 12th. So, at first, I'll be announcing the results of the essay competition for children belonging to standard 9th and 10th. The first prize goes to Miss Astitva Jaiswal, Standard 10th, Tinobli CMRI. She is the daughter of Mr. Amit Jaiswal. So double congratulations to Amit ji. The second prize goes to Miss Ashi, Standard 10th, Tinobli CMRI. She is the daughter of Mr. Amrit Kumar. The third prize goes to Miss Advika Singh, Standard 10th, Dinobli CMRI, and she's the daughter of Dr. Siddharth Singh. So, sir will collect the prize on her behalf. Now we move on to the announcing the winners of the oral presentation for the research scholars and project assistants, the kind of slam that we had earlier this morning. And the first prize goes to Miss Priyanka Shukla. She is pursuing her PhD under Dr. Mende sir. The second prize goes to Abhishek Pandey Barat. Abhishek. Jaldi. The third prize we have joint winners Ajay Kumar Singh and Sandhyaswini Kumari. I now have the results for the essay competition of the children belonging to standards 11th and 12th. So the first prize goes to Miss Akriti Kumari. She is standard 12th from Indian School of Learning and she is the daughter of Mr. Sanjeev Kumar. Akriti. Can we have a loud round of applause for her? The second prize goes to Mr. Jayesh Kumar Ahirwal, Standard 11th, Doon Public School, CMRI. And he is the son of Dr. Bhagirath Ahirwal. The third prize goes to Miss Nehan Sharma, Standard 12th, Shri Shri Suryoday Singh Smriti Gurukulam Dhanbad. She is the daughter of Mr. Alok Sharma. That's all. Congratulations to all the winners and to all the participants. Your efforts are extremely praiseworthy. Ladies and gentlemen, can I have a loud round of applause for all the participants? Thank you. Now, to formally present the vote of thanks, may I kindly request Dr. Sujit Kumar Mandal, sir, to deliver the vote of thanks.
Good afternoon, respected dignitaries, those were invited for this Environment Day, our respected director, Dr. J.K. Pandey, my seniors, colleagues, ladies and gentlemen and children who have participated in this event and have come a long way to this. I welcome you all. First of all, this Environment Day is a very important as the total scenario is concerned of today's India or today's world. So considering this, all these aspects, we must say that our requirement is food security, diversity, and also with respect to climate change, we have to be very careful in this to protect our next generation, our future world. So first of all, I thank, considering to the need of the requirement, Mr. Prabhat Mandal, Prabhat Kumar, attended this DGMS. I congratulate when I give him a well applause that he within a few days time, in spite of his busy schedule, he accepted our invitation and came to our institute and gave a deliberation about the requirements of so far as mining and oil industry is concerned and how to protect our environment. From the core of my heart, I also so thankful to Mr. Sanjay Singh, Director Technical BCCL, who has also deliberated some issues related to our solar panel system and carbon emission, greenhouse gases. And we are in the way to this all these aspects, but he should be. We should communicate him about this, and we should have uh, some interactions with him related to this. And we are very much thankful that he has given such a issues that are being that has been thought of by BCCL. Then I am very much thankful to Mr. Santosh Kumar Singh, who is head Sustainable Group, Adani Group,
and has well communicated about the transition of energy transition and the renewable energy, wind power, solar system, and how they are now implementing ultra super critical power generation for greener environment. Then I should also thank Professor A.P. Dimri, who has who is also the director Indian Institute of Geomagnetism, and who has very within a very short time he could explain us about the climate, how it is changing, and how it is differentiating within our plain land and the Himalayan land, how the Himalayan land are becoming drier nowadays due to the climate change, how the marine warming is nowadays, how marine warming is taking place, and how the flooding arrangement, the flooding of the some regions are now shifting from one region to the another, and how the gravity and buoyancy is helping towards the precipitation in our country. The other aspects he has also told about the physical interventions related to temperature, and how he has also said that water flow due to glaciers melting, the water flow may be doubling by 2050, but however after that it may reduce because with the scarcity of glaciers. I'm also thankful to our director who has taken his utmost effort with and to bring this into a grand event, because as we know that no event can be carried out in a single day's plan without a continuous effort or a team effort from team effort. So I also thank to the total team who has directly or indirectly played a vital role in this environmental day. Last of all, I would also thankful. I'm also thankful to the participants who have also participated in the various events, and also the jury who have taken their effort out of their normal duty to do the event in such a short time. Thank you one and all, and I also want to thankful to our civil department, electrical department, and other departments who have directly or indirectly involved in this to get this event a grand success. Thank you.
Thank you, sir. This event has truly enlightened us with fresh perspectives. And as our actions today shape the world of tomorrow, may this Environment Day inspire us to be more mindful of the environment, and let us all take positive steps to ensure a sustainable future. Now, as we come to a close, I request all of you to rise in the respect of National Anthem. Sir wants to speak.
Just before the conclusion, I thought I must say something. First of all, thanks. As vote of thanks has already been given by Dr. Mandal. So thanks to everyone, those team members and the leaders who took initiative, Dr. Abhay and his team for organizing this event. So thanks to all, each and every one of you. And जो बच्चे आए हुए उनसे एक गुजारिश है, अनुरोध है, बच्चों के साथ में बड़ों से भी अनुरोध है। क्या आप जानते हैं कि एक साल में हमको कितने ऑक्सीजन, एक इंसान को कितना ऑक्सीजन की आवश्यकता होती है? मतलब हमारा जीवन कैसे चलता है, मतलब बेयर मिनिमम रिक्वायरमेंट क्या है जीवन में, जिसके बगैर हम जीवित नहीं रह सकते, वो पता है ना? क्या है? एक तो ऑक्सीजन है, दूसरा पानी और भोजन, है ना? इसके बगैर तो जीवन पॉसिबल नहीं है, ठीक है ना? तो ये ऑक्सीजन एक साल में कितना आवश्यकता होती है और ये देता कौन है, कहाँ से आता है? तो अब तो भविष्य में हो सकता है, जब तक जो छोटे बच्चे थे ना, जो छोटे बच्चे बड़े हो जाएंगे, पापा के जितने बड़े हो जाएंगे या मम्मी के जितने, तब हो सकता है कैनिस्टर में मिलने लगे ऑक्सीजन। अभी तो फ्री में मिल रहा है। कहाँ से आता है ऑक्सीजन? तो पेड़ों से आता है। तो पेड़ क्या करते हैं, कार्बन डाइऑक्साइड एब्जॉर्ब करते हैं, ऑक्सीजन छोड़ते हैं। तो आप लोगों को एक प्रण लेकर जाना है, छोटे बच्चे, बड़े बच्चे और बड़े लोगों से भी, कि एक इंसान को एक साल में जो 550 लीटर्स का एक दिन का रिक्वायरमेंट है, 4 मिलियन लीटर्स का एक साल का रिक्वायरमेंट है। जीवन काल डिपेंडिंग ऑन द एवरेज लाइफ, उससे मल्टीप्लाई कर लीजिए। तो 2 पेड़ एक साल में, वो बड़े पेड़ जब लगाएंगे तो वो ऑक्सीजन उतना नहीं देगा। जब बड़ा वृक्ष हो जाएगा तब वो उतना ऑक्सीजन देगा। तब तो ये कहा जाता है कि कम से कम 18 पेड़। अब ये कैसे काउंटिंग किया है, क्या एनालिसिस किया है, मुझे नहीं पता, परंतु आप लोगों को प्रण लेना चाहिए कि कम से कम एक साल में 2, क्योंकि आप तो लगा रहे हैं, आपके जैसे और महाप्रभु लोग होंगे जो नहीं लगाते होंगे, जीवन काल में कभी नहीं लगाएंगे, तो उनका भी आप ही को लगाना होगा। तो हर साल कम से कम 2 पेड़ जरूर लगाइए। इन्हीं शब्दों के साथ धन्यवाद।
Thank you, sir, for the wonderful message. We'll try our best to fulfill this pledge. And now I request all to kindly rise for the national anthem. Thank you all. The tree plantation drive was conducted earlier because of the paucity of time for the dignitaries. And I also request all of you to please be seated. We have arrangement of some refreshments which will be served in your